In the last episode, we saw the two pillars of the CE approach: massive data sets and powerful quantitative models. Today, we uncover the foundation they both rest on, a step so fundamental it changes everything about how we design experiments. That foundation is the first step, a major shift where we ditch the core of theory-driven design and embrace a stimulus-driven approach. This might be the most surprising and powerful shift in the entire CE method. Here's the story we'll walk through today in 4 parts. First, we'll see exactly why the traditional theory-driven method hits a wall. Second, we'll confront a deeply counterintuitive paradox about how to build theory. Third, I'll show you the solution, a new way to design experiments. And finally, we'll see the incredible outcomes this new approach delivers. We all know the classic approach, theory-driven design. You have a hypothesis, you manipulate variable A and B, and you see what happens. And it works, but only for small, isolated questions. The fatal flaw appears when you aim for a comprehensive theory. To understand a system like visual working memory, you'd need to manipulate not 2, but 10 or more factors simultaneously. And that isn't just hard, it's practically impossible. Let me tell you how I learned this the hard way. Before CE, I was determined to crack multi-item memory using theory-driven design. I went to the literature and made a list of all the known factors. First, chunking. Second, interactions between items. Third, categorical effects. Fourth, regularity. Fifth, the quality-quantity trade-off, and several more. My goal was an ambitious 10-way factorial design, but the difficulty doesn't add up. It multiplies. After a month of struggling, I had to surrender. The task of defining each factor and then creating thousands of perfect stimuli to represent their combinations is simply unworkable. Now you could say maybe I just wasn't skilled enough, but look at our entire literature. You'll find 3-factor designs sometimes. You will never find a 10-factor design. This isn't an accident. It's evidence of a fundamental limitation of the theory-driven method itself. This brings us to the paradox of theorizing. Our ultimate goal is to build better theories, but the very worst way to do that is to start by rigidly defining every detail of that theory in advance. That path is guaranteed to fail. The counterintuitive solution is to do the opposite, to step back, let go of control, and let the data itself reveal the path forward. This isn't abandoning theory, it's actually the smartest, most efficient strategy for building it. So what's the alternative? Stimulus-driven design. We stop trying to predefine and manipulate every theoretical factor. Instead, we just define the entire universe of possible stimuli we're interested in, like every possible combination of 4 colors on a color wheel. Then we randomly sample from that space. This approach, inspired by revolutions in AI, uses natural variation to do the heavy lifting of experimental design for us. You might ask, if you're not looking for specific things, how do you find anything? The answer is, we are looking, but we're using a wide-angle lens, not a microscope. As you can see from these examples, we trusted that if classic effects, like interactions between items or categorical effects, were real, they would be naturally embedded in the very fabric of how colors are remembered. Our job wasn't to force the data to fit our predefined boxes. It was to listen to what the data was telling us, and it worked. Every classic effect was not only present, but was captured with a clarity that theory-driven designs often miss. Let's be direct. Theory-driven design fails beyond 3 factors. It hits a wall. Yet our case study, using a stimulus-driven approach, captured a dozen factors simultaneously. This proves the problem was not the comprehensive study itself. The problem was trying to achieve it with a theory-driven design. But the most exciting part isn't just confirming what we already knew. It's discovering what we didn't know. As Karl Popper said, our ignorance is necessarily infinite. By not restricting ourselves to a predefined list, we opened the door to surprise. We discovered 4 entirely new mechanisms, like concentration and crosstalk. This is the true power. This method doesn't just test existing theories, it builds new ones from the ground up. There's a specific reason why stimulus-driven design leads to unknown findings. In theory-driven research, we likely oversample certain regions of the stimulus space because they correspond to trendy topics. We could ignore entire regions for years without realizing it. In contrast, random sampling of the stimulus space ensures we cover all regions reasonably well. This systematic coverage can lead to new discoveries. Now, a critical clarification. Stimulus-driven does not mean we're wandering aimlessly. We still use our hard-won theoretical knowledge to set essential boundaries. We call this creating a factor-informed stimulus space. Think of it as using minimal sufficient constraints to isolate the phenomenon of interest. In the case study, I made one simple decision. I fixed the number of items at 4 in order to study multi-item memory. Compare this one simple constraint to the impossible nightmare of trying to predefine a dozen complex factors. This approach is vastly more feasible and provides the focus we need. So, to wrap up, the old way of designing experiments has a hard ceiling. Stimulus-driven design is the key that unlocks the next level of psychological science. It provides a feasible, powerful path to finally conduct the precise and broad studies we need, by letting the data itself be our guide. Let's be clear, this isn't a radical new idea. Data-guided theory building, or abduction, has always been a cornerstone of scientific discovery. Even in physics, the pinnacle of theory-driven science, some of the most profound breakthroughs, like Kepler's deciphering of the laws of planetary motion from Brahe's data, began not with a perfect theory, but with a willingness to be led by the evidence. I am not proposing something strange, but simply arguing for a return to this fundamental principle. When we are ignorant, we must be willing to let the data guide us to the theory. Now, with this rich theory-agnostic data in hand, what's next? In our next episode, we'll fire up the engine that turns it into theory, exploratory model building. See you then.